So we are on analyze phase, and we learned Disco last week, and I'm sure that it's a powerful tool for you to use. And in analyze phase, we are dealing with the data, and as I mentioned to you, data is bound to abound. The data is bound to increase in our daily life and in business, and those who can handle data and gain some insights out of the data, they will be a valuable asset to any company, any organization. And this data analysis can be classified into three areas. First one being data preparation, and second, data visualization, and the third is data inference. So as you saw in Disco, Disco can be a powerful tool. However, if you don't have the data, for example, the timestamp, starting timestamp and ending timestamp, and then you need to have who handled that procedure and what kind of activity was done. That data has to be there. If the data is not there, then although the software is powerful, you cannot use it much. So data has to be collected and prepared, and that's one of the most difficult thing for us to do in data analysis. So data cleaning, data preparation, that's the challenging thing to do. Once you do that, then we go to data visualization. You want to understand the data visually in various perspectives, and it can be done by slicing and dicing and visualization. Once you do that, now we go to data inference, where you apply advanced statistical methods to gain insights about the data. That's data inference. So if we take a look at the data preparation, data extraction. For example, you might have the data scattered around many other departments. For example, the time stamp will come from your secretary, and what activity you did may come from logistics department, transportation department, or human resource department. And those things are scattered around, and how are you going to put them together? And that's an extraction, right? Sometimes the data has to be transformed. Say we have the data from Europe, and the date format is different. So we have to change that to American format, and that's a transformation of the data. Or sometimes you may have to change the data from text data to number, or number to text, right? So that transformation has to happen. Now, we also need to connect the data. For example, we have a community, say you are doing data research about your company, and you also need to collect the data from, say, Walmart in Deptford and Walmart in Sewell and other places, and the data are housed in different stores, and you have to connect them together. That can be done. Or you can connect them with regional data, right? So, or people data, or they can be connected to the departmental level data. So that connection can happen in this data preparation stage. So it's a time-consuming process. It takes a lot of creativity and skills, such as database or coding skills, to prepare for data. And if you have done that, now we can move on to the data visualization phase. There we have exploratory description and exploratory description. Exploratory is such as mean and max and minimum, and those descriptive statistics we can talk about in data visualization. Explorative data visualization is like New York Times. If you go there, you can click on it and drill down from state level to county level to city level or personal level. You can keep on drilling down, and that's explorative data visualization, which is also very important area, and it requires significant skill set to do that. And now data inference stage, you have tests such as hypothesis test and ANOVA, analysis of variance, and regression test. So if you collect the data through your measurement, that happens in your measurement base, and now you are able to conduct hypothesis test. And then if you have more than 2 samples, then you are going to use ANOVA, analysis of variance, or you can use more advanced methods such as regression method for investigating causal relationship between dependent variable and independent variable that can be done under data inference phase. And today in this class, I'm going to be talking about hypothesis testing and how to do that. And next class, we will discuss ANOVA, analysis of variance. And if we have the time, we'll cover also regression too. So let's talk about hypothesis test. So hypothesis test is about coming up with a hypothesis and verifying whether this hypothesis is holding up or not. And we have to understand that there are different types of hypotheses. And hypothesis testings are such an important thing because we hypothesize, we live in hypothesis all the time. For example, your value for the process might be, yeah, I want to reduce the time from 1 hour to 30 minutes, or 30 minutes of wait time to 15 minutes. And you are assuming that the process is taking about an hour or 30 minutes. And is that really true or not? Can we say that this process is taking us at least 30 minutes of wait time? It may be true for one customer, but it may not be true for all the customers. But can we say for this entire experience, on average, it takes 30 minutes? Can we say that? And we can test that using hypothesis tests. Or sometimes we want to compare the hypothesis testing with other groups. For example, day shift are performing better than night shift. In day shift, the production was 100 per hour, but for night shift, it will say 90 per hour. But can we say there is a statistical difference between these two numbers, 100 and 90? Just number says it's different, but statistically, we may not be able to say there is a meaningful difference between them. So we have to verify the difference, whether they are meaningfully different, significantly different, statistically different, and that can be tested using hypothesis test. So, having a hypothesis testing in your skill set is very important in business process improvement, because now we have to prove that, oh wow, there is a significant problem, and by analyzing it, we prove statistically that, oh yeah, this is a significant problem, and we can deal with that. And after improvement measures, you show to the stakeholders saying that, yeah, we have implemented the corrective measures, and we found that now we have less time for wait, or more production, or more efficiency. We saved more money. So those things can be tested using hypothesis tests. So that's why we are learning this hypothesis test here. And first of use of hypothesis testing in improvement. Hypothesis test in Six Sigma. How do you conduct your hypothesis testing in Six Sigma? First of all, you want to observe the facts that you have been seeing, and then through those facts, you want to ask questions relevant to your methods. For example, you have this is 608 cases from DISCO analysis, this purchasing process. And we asked 3 questions last time. The first question was, why is it taking longer? Some cases are being resolved very quickly, but some cases are just there for 108 days, 200 days, 50 days. Why is it taking so much time, right? That's a good question. And you can also ask question, why are there cases that are not conforming to the regulations that you have, right? So some cases, I believe it was 10 cases, were jumping the approval process, and they processed the supply invoice right away. So why did that happen? That has to be investigated there too. And those questions you ask, and then you say, oh, probably it's because a certain person is in charge of that problem, and you want to collect the data and test whether that is true. You can verify that. So you have facts and you ask questions, and that will be your conjecture, and then you are going to verify your conjecture by conducting hypothesis test. And there are a few types of hypothesis testing, and let's delve into that. This is critical guidance for you. So you want to see 2 things. First one, whether this is mean test or proportion test. Are you asking about mean or proportion, right? So if you are talking about the average of something, then it's going to be mean, right? So if you say, yeah, on average, 70% of our products are being sold in North America, right? In that case, even though you are talking about percentage, you said you use the word average 70%. So in that case, I think it's a mean test. However, if you just say, yeah, just 70% of our products are being sold in North America, then it's going to be proportion. So you want to distinguish between mean test and proportion test, and you use that as the guideline to classify them into different groups. So is it mean test or proportion test that you want to define that? And another thing that you want to look at is number of samples. That's another thing that you want to examine. If there is 1 sample, that's 1 sample test. If there are 2 samples, then that's 2 sample test. And if there are more than 2 samples, then we can say there are more than 2 samples. The reason why we ask the number of sample and also mean or proportion test is because depending on the nature of the data and test that you are conducting, you have to use different statistics and formula for that. So that's why you have to use mean or proportion, or 1 or 2 or 3 samples, or more than 2 samples. That distinction have to be made for you. So here's the formula for that. So if you are dealing with the mean test and you have only 1 sample, then you are going to use this formula called Z distribution, 1 sample mean Z test. That's X bar minus mu over sigma over square root of n. So X bar is sample mean, mu is population mean, and sigma is standard deviation of your sample or population, and n is number of sample from your data. So that function a formula you have to use. That's why you have to remember that. And then we have 1 sample proportion test. In that case, Z equals P. P is probability from your own sample minus pi. Pi is from your population or your question itself. So that's pi, and over square root of pi parenthesis 1 minus pi, and square root of n divided by n is the sample size. So that's another function that you have to use for that. And then we have 2 samples test. And this is a two-sample mean test. When you have two-sample mean test, the null hypothesis is mu S, or whatever group you might be using, that mu has to go there. So mu is less than or equal to mu the other group. And alternative hypothesis says mu S is greater than mu something else, right? So you are comparing two means of two groups, and that's your mean two-sample test. And then at that time, you're going to use this formula, z equals x bar 1 minus x bar 2 over square root of s1 squared over n1 plus s2 squared over n2. And lastly, proportion test, and it's two samples. Then you are also comparing two proportions against each other. So pi 1 is less than or equal to pi 2, and pi 1 is greater than pi 2. And then at that time, the formula is a little bit complicated. Z equals P1 minus P2. These are from your sample data over square root of PC. PC is pooled probability. PC equals X1 plus X2 over N1 plus N2. X1 is the number of the samples out of your data that follows special characteristics. For example, it could be number of defective, or it could be number of excellent project, or it could be type A or type B. So the kind of characteristics will be counted there. And then you use sample 1 and sample 2 and pull them together, and then calculate the z value, and you have to compare them together. So that's a formula that you are going to use for hypothesis test. And now let's talk about steps for hypothesis test. There are 5 steps in hypothesis testing procedure. The first one is defining the hypothesis. We first need to define the hypothesis. What kind of hypothesis are we testing? That has to be defined. And in this case, you have to understand whether this is one sample or two sample, mean or proportion test, whether we have one and is it greater than something else, or equal, or is not equal to something else. That has to be defined in the hypothesis. And in step 2, you have to define the statistic. So if you know now hypothesis test, then it will be natural for you to define the statistic yourself. And the third thing is you have to define the rejection region. Where is the rejection region in your hypothesis testing? And you have to see whether your hypothesis will be fall into rejection region or out of the rejection region. And fourth one is calculate the statistic. So here you are going to derive your own z-value for that. And lastly, you will need to draw a conclusion for that. So after calculating and comparing the statistics with your own rejection region, then you can see which is working, which is not working. So in that way, you can make the conclusion. And at the time, again, you will be using this guideline. So when it is mean and one sample, you use this z function, and it is proportion, then you use this one, and so forth. If there are more than 2 samples, then you have to use ANOVA, because this formula cannot handle the situation. So if you have more than 2 samples, say late group and daytime group and evening group, then you have 3 groups, right? At that time, you have to use this ANOVA. Or you can have 4 groups, 5 groups, right? So A group, B group, C group, D group, and F group. How are they doing better? And we have 8 groups in our presentations. Then you have to use ANOVA, or you can classify them into certain groups and then compare. In that case, you will have to use ANOVA.